Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about bioorganic chemistry. So, bioorganic chemistry is a chemistry which integrates organic chemistry and biochemistry. Organic chemistry and biochemistry. Now, what is organic chemistry and what is biochemistry? Organic chemistry, everybody know that organic chemistry is a study of the compound of carbon, and bioorganic chemistry involves the study of biological process using chemical method. Organic chemistry method are used to synthesize biological molecules and to examine their structure to investigate the biochemical reactions. The compound of carbon are the central substances of which all living things on this planet are made. Like you can see the food, whatever we are eating, clothes we are wearing, pharmaceuticals, we are taking everyday medicine, DNA, the giant molecules that contain all genetic information for a given species. Protein, blood, muscles and skin, enzyme catalyze the reaction that occur in our bodies. Compound which furnish the energy that sustain life. Now my friend, classification of organic compound. According to the character of chain of carbon atom, organic compounds divided into two parts, acyclic and cyclic, saturated and unsaturated. In cyclic system, there is a two classification, carbocyclic and heterocyclic. Carbocyclic, you can see the examples. Alicyclic, this compound is aromatic, and alicyclic. Aromatic examples is benzene, this is cyclobutane. Now heterocyclic is two compound here, aromatic and non-aromatic. You can see the pyridine, this is the aromatic pyrrolidine, this molecule is non-aromatic. Now my friend, according to the functional group, all organic compounds are grouped into classes based on characteristic features called functional groups. A functional group is an atom or a group of atoms within a molecule that serves as a site of chemical reactivity. The most important functional group with the key structure element and a simple examples. You can see the functional group and its name, general structure and name, and examples. Example, halogeno, you can see the fluorine, chlorine, bromine and iodine. R is equal to halogenides, and you can see ethyl chloride, for example. If OH functional group, it represent hydroxy groups like alcohol, phenol. Examples, you have the methanol, you have the phenol. Alkoxy group, OR. Examples, ether. Mercapto group, this is very important functional group, SH. Mercapto group, RS thiol, and alkyl thio group, SR. Now you can see the sulfur group, that is very important for the beginner. What is the sulfur group? Sulfur group is H double bond O, like this you can see, and the general structures and name sulfonic acid. Now amino group, you know the primary, secondary, tertiary amine, this is the examples. Nitro groups, NO2, you can see the nitro compound. Carbonyl groups, you can see here aldehyde and ketone, and carboxyl group you can see here. So representations of a structural formula. You can see how you will write the molecular formula like propane, propyne, ethanol, ethanamine. Show the bonding between the atom of molecules and the lone pair of electron that may exist in molecule. That is the dot formula. This is the dot formula of propane. You can see here. Dash formula. Why dot? Because it is represented by dot, dash. This you can see that this is bond representing the dash, and this is the condensed formula. There is no dash and dot. Then you can see here this is the condensed formula of, and like that you can represent. Now my friend, bond line formula, shorthand structure. Rules for shorthand structure. Carbon atoms are not usually shown intersection end of each line. Hydrogen atoms bonded to carbon are not shown. They are shown in cases when they are attached to heteroatom. All atoms other than carbon and hydrogen are indicated. You can see the condensed and semi-dash and bond line formula. So this is the condensed formula, this is the semi-dash formula, this is the bond line formula. Now you can see here the structure of vitamin, retinol, and the molecular formula, you know, C20H30O. Three-dimensional formula. Now here you can see hashed wedged formula. Hashed, you can see the dotted line and wedge. So you know the tetrahedral form of methane. So four bonds are not in the same plane. So how you will represent at the three-dimensional formula. So bromochloromethane, you can see the three-dimensional formula are represented using hashed wedge and wedged bond. Now nomenclature of organic compound. You know the examples of non-symmetric trivial names. In chemistry, trivial name is a common name or vernacular name. It is not scientific name. For example, you can see here the structure of morphine, named after Morpheus, the Greek god of dreams. So this is the morphines. You can see the lactic acid structures, citral, malic acid, acetone, retinol, acetic acid, alanine, and oxalic acid. IUPAC rules. A set of rules that is used to name organic compounds has been devised by International Union of Pure and Applied Chemistry. A chemical name has three parts in the IUPAC system: prefix, parents, and suffix. What is the prefix? Where are the substituents? Parents, how many carbons? And suffix, what family? So step 1, find the longest continuous chain of carbon atom, and this chain determines the parent's name for the compound. What is the criteria? Criteria of determining the longest chain for a cyclic compound. Longest chain with the functional group of the highest priority. You can see here and write it down. This is very important. You know the functional group and what is the priority out of the functional group. That is the important. You keep in your mind when you are doing the nomenclature if you have 1 and 2 functional groups together. So decreasing priority of functional group, you can see the COOH, sulfonic acid, acid derivatives, cyanide, aldehyde, ketone, OH, thiol, and NH2 groups. Now you can see the chain containing maximum double and triple bond. 2-butyl 3-pentanoic acid. You can say 1-chloro-2-butanone and 3-oxobutanoic acid. So functional group depending on its priority in a concrete compound can appear in the name as prefix or suffix. When two chains of equal length complete for selection as the parent chain, they choose the chain with the greater number of substituents. 2,3,5-trimethyl 4-propyl heptane. If compound is cyclic, aromatic, or heterocyclic ring to which a group of highest priority is attached is considered as a main ring. You can see the group of the highest priority. The main cycle with group of highest priority is cyclopentane, and substituent 3-hydroxyphenyl 3-hydroxyphenyl cyclopentane carboxylic acid. Now you can see the step 2, number of the longest chain beginning with the end of the chain nearer the highest priority group or substituents. If you want to write the nomenclature of this compound, 3-hexanone, not 4-hexanone. Why? The due to priority order. Substituents, you can see this, not this one. So my friend, cyclic compound, you know, the 4-hexyl 2-methyl cyclopentane carbaldehyde, not 3-hexyl 5-methyl cyclopentane carbaldehyde. Why? Due to the priority order. You can see the 2 plus 4 and 3 plus 5. 3 plus 5 greater than 2 plus 4. You know the general mathematics. Now do the nomenclature of this compound. 3-hexyl 4-methyl 2-cyclopentene carbaldehyde, not 4-hexyl 2-methyl 4-cyclopentene carbaldehyde. What does it mean? So you can do the step 3, use the numbers obtained by the application of rule 2, designate the location of the substituent groups, 2-methylhexane and 3-methylheptane. The parent name is placed last, the substituent group preceded by the number indicating its locations on the chain is placed first. When 2 or more substituents are present, give each substituent a number corresponding to its location on the longest chains. So you can see the 4-ethyl 2-methylhexane. The substituent group are listed alphabetically. When 2 substituents are present on the same carbon, use the number twice. So 3-ethyl 3-methylhexane. When 2 or more substituents are identical, indicate this by the use of the prefix di, tri, tetra and so on. So 2,3-dimethylbutane and 2,2,4,4-tetramethylpentane. When the branch first occurs at an equal distance from either end of the longest chain, choose the name that gives the lower number at the first point of the difference. You can see 2,3,5-trimethylhexane, not 2,4,5-trimethylhexane. So suffix of some classes of organic compound, principal group, class of compound and suffix. You can see the COOH group, carboxylic acid and suffix oic acid. Ketone, the suffix 1. You know this is the very basic chemistry. Just the representations, that is very important. Methane, if you remove this hydrogen, then it becomes methyl, then ethyl, then propyl, then butyl. So my friend, from here I will discuss in my next video. So in this complete lecture I will discuss about the bioorganic chemistry, which is a combination of organic chemistry and bioorganic chemistry. Thanks for watching.